Hey everybody, it's Michael Antonio, and welcome to Encoding Custom Resources with Transforms. The use case today is custom resource property encoding. The problem is that CloudFormation passes all of the data that you send to your custom resource as strings. So if you pass numbers or booleans, they're passed as strings, and now you have a coercion problem. You have to coerce the strings into numbers and the strings into booleans or whatever type you want. Um, and this is really a very big problem. And there are a number of different ways to get around it. My standard operating procedure is to base64 encode all of the properties that are sent to the custom resource. And that works great, but the Lambda has to decode those properties before using them. Another thing you can do is you can stringify them, but again, you have the same problem, which is that you have to decode the properties. So, sort of six of one, half a dozen of the other, as far as I'm concerned. I like base64 encoding. So I created an encode resource transform that works across CFN resource properties and encodes them all together. This way, I don't have to rewrite this code over and over every time I create a custom resource. If I want to encode my my properties, I just can add an encode resource transform, and that will encode all of the properties for me. Really simple. So the thing about this is that it's not possible to work across properties using the normal escape hatch methods like addOverride or addPropertyOverride, because those work on single properties. The encode resource transform runs after all property modifying transforms run during the underscore writer pass, and I'll show what that means. And it's demo time. Okay, so I have a stack here for today's lesson, which is called base64 encoding, and that's in my CDK orchestration examples project on GitHub. And what I'm going to do here is I'm going to turn logging on to debug, because we are working with transforms, and transforms write out what they do in debug logging, so that way I can see everything that's happening. And I'm going to create a task. So I've used this task before. This is the greeting lambda task, and this basically just writes out the greeting that you pass to it. So it's pretty simple. It's more or less an echo lambda. And then I have this echo custom resource. And what this is going to do is since the greeting lambda task is a task, that means that it's a custom resource. And so it has custom resource properties. So what I'm going to do is I'm going to echo that custom resource out first, and then I'm going to echo it out again after it's been encoded. So these two are transforms, and transforms basically act on raw CloudFormation that is produced either by a resource, which is what I'm doing in this case, or by a stack. And if you're interested in learning more about transforms, there'll be a link in the description. Okay, so how do these work? Well, the thing about transforms is that they have a target. Now, normally, if you add a transform to an L1 or an L2 resource in the CDK, it will just work. But in this case, we have something that's a little more complicated. I'm going to come over here, and I will show you. Here's the base64 encoding class. We're in the AWS toolkit. And under this class, there's the greeting lambda task. This is our custom resource. It has some things under it, including lambda task, which it has a resource under it, which also has a resource under it, which has a default under it. And that default is actually the custom resource. So if we come over to our generated template and we look for our custom resource and we go to the very bottom of it, what we're going to see is that it's base64 encoding, that's the stack, and then greeting lambda task, that's the task I created, and then it's quite a few levels down before you actually get to the custom resource. So what I'm going to do is I'm going to show you that the Lambda task has under it, a few levels down, this encode resource transform. And this is the thing that's going to work on all of the properties of our custom resource and encode them all together. And then here you can see at the level of the greeting lambda task, which is the top level construct that I created, here I added an echo custom resource. And so that, while that is under the lambda task, it has to act a few levels down under this default. And so you can see that here under transforms, I have echo custom resource shim. So this is our CFN resource, and I've added orders to it so that I can run transforms in a particular order, and I will have a link to the lesson on ordered transforms. But basically, these underscore constructs here are here for the purpose of allowing me to run transforms in a particular order. So the first thing that's going to run, because none of these other ones have children, because I'm not running any string transforms, I don't need to stringify or parse. But under transforms, we have this echo custom resource, and that's this one here that I added. Then under writer, this is where we encode resources. And the reason we do that is because we want to do it after string transforms run so that you as the user can run string transforms on the entire template that you're given, or you can run transforms on that template as well. And string transforms run on the string representation, and transforms run on the object representation of the template. And then I'm running the encode resource, and then down here I am doing this echo custom resource after encode. So how did I get this echo custom resource to appear down here, and how did I get this one to appear up here? Well, as you can see, echo custom resource, instead of targeting an L1 or L2 construct, it's targeting a custom resource. So find custom resource will return you a custom resource under the scope, and that's the scope of the transform that we're passing, and it will return one that has a resource type of the form custom : or AWS CloudFormation custom resource. And that's how I can say I want this transform to be targeted to a custom resource. Now, if I want to change the order in which a transform runs, then I can override get order. And so I created this echo custom resource after encode so that it will encode run after encode resource runs, and encode resource runs in the writer order, and therefore I want this echo to also run in the writer order. Okay, so let's take a quick look at encode resource and see how it works. So encode resource is a transform. It recognizes service properties. These are properties that should not be encoded. And right now, there are two of them. One is service token, and the other one is service timeout. And this is a static read-only, so that if you needed to add more in the future, you'd be able to do that without my help. You could just push a new service property into this. But for now, this is supporting all of the service properties that exist in CloudFormation for custom resources. The order of encode resource, as I said, is writer, and that is why when we look over here, we can see that, it's in the other one. It's in the other project. But in the other project, you can see that encode resource runs in the writer order. And the target for this is a custom resource, because that's what encode resource works on. It works on custom resources. Therefore, it has to work basically the same way that echo custom resource does, because you might be adding it to an L1, L2, or L3 custom resource, which is very common since most of the custom resources that you will deal with are L3 resources. So in the apply thing, we check to see if the properties have already been encoded, in which case we don't encode them. Or if there's a service token, or if there's not a service token, then it doesn't need to be encoded. So we just continue and on. And here, I basically say delete all of the service properties from the resource properties for the resource that we're modifying and save those off in a separate variable. And then our encoded properties will be the service properties, which need to not be encoded, and then the encoded properties, which I will base 64 encode. And this will create a token for us. And then we set the resource properties to these now encoded properties. So that's how encode resource works. And so what does that do? And that is why I have these echoes. So you can see at the beginning of this constructor, I'm writing out base64 encoding constructor begin. And at the end, which isn't very far down, I write out base64 constructor end, or base64 encoding constructor end. And so that's our stack. Literally all that I'm doing in the stack is creating this Lambda task and echoing before the properties are encoded and after the properties are encoded. So let's take a look at what we end up with here. So the first thing that we see here is that on our custom resource, which is, as again, an L3 custom resource, so it's pretty deep in there, we are going to run echo custom resource. And so what that will do is that will write out our template for the custom resource. And so that there's only one resource in here, which is this custom Lambda task. And it has a service token as a property. It also has create because it's going to do a Lambda invoke. And then on update, it's also going to do a Lambda invoke. So that update is another property. And then down here we have a response buffer field of payload because I'm calling Lambda invoke. I need to decode a return value, and therefore this is basically my drop-in replacement for AWS custom resource, and it has this response buffer field, and that allows me to say, oh, if this field is present in the result, then you should be using the this, and you should basically read the buffer, and the results of this, that's going to be JSON, and therefore we're going to be using the JSON from this instead of the JSON that got returned by the Lambda call. And since we didn't request any outputs from it, there's no requested outputs, so there won't be any data returned by this. And then lastly, we have, and you can see it up here where it says run resource always. If you remember the unit that I did on how to do escape hatch constructs. This was an escape hatch construct that ensures that a custom resource is always run, and this one adds this salt value, and the salt value is a number. Okay, and so those are all of the properties for my custom resource. So then the next thing that happens is the encode resource transform is run. And that is the one that will encode all the properties of our resource. After that, it's going, and you can see that that runs as part of the writer. And so that's the writer order. So here's our resource, this default here. There's nothing here, so it doesn't run anything. Then it runs this echo custom resource. Then it runs encode resource, and that's where we are here. And that's in the writer order, and then it runs echo custom resource after encode, which is also in the writer order because that's how we set it up. And what we're going to see here is that since we're doing an echo, it's going to write that out as an info log line. I will also post a video about how to do scoped logging, which is basically what I'm using to do my logging here. And here, so you can see, once again, it's writing out my custom Lambda task, and it writes out the properties. And so service token is still here. That's the same service token that you saw up here. No difference. Same exact provider framework on event for AE. Same thing down here. And then it has this encoded properties. And since, as I said, we're basically calling FN base 64, and that returns a token, we get a token as the result of this. And that token will get resolved before the CloudFormation gets returned to be merged into the rest of the template, which is this template here. So here's our template, and here is the Lambda task, which is in the template, and you can see that it has service token, and when this token has been resolved, and I will also put a link for my video tokens in the description, I get the encoded properties. And the encoded properties, since there are these references here in it, it's going to be a base 64 encoding with a join under it, and then that join, basically it's joining with an empty string, and it is joining basically my parameters with CloudFormation references to I believe that this is a function, and it's got this function in here just a couple of times. So, and at the end of this, what you will see is that my response buffer field, requested outputs, and salt are here. So basically, everything that you saw as a property of the resource has now been moved into encoded properties and base 64 encoded, and that's just going to be really useful for us in terms of numbers coming in as numbers, booleans coming in as booleans, and all of that kind of stuff. And if we go back to encode resource here, you can see that it shows you how to do the decoding, which is just to do a JSON parse, and then you just do buffer from the encoded properties base 64. So this part here, this buffer from, is the part that is doing the base 64 decode, and then that is coming back as a UTF-8 string, and then we're just doing a JSON parse on. And that becomes our new resource properties, and that is very useful because now I have my properties, and the numbers are numbers, and the booleans are booleans, and I don't have to do any variable coercion because I encoded and decoded the properties. So this is basically a different this is basically a different use case for transforms, and I think it's pretty cool. So now that we've written out the encoded properties here, and we've done our echo after encode, it will write down that it successfully applied, and then it will list all of the transforms that were applied. And so that was the echo transform, the encode resource transform, and the echo after encode transform. And then down here, you'll notice that it says successfully applied no transforms to the stack base 64 encoding. And we get this because whenever you add transforms to anything under a stack, the stack also is enabled to host transforms at that same time. Because at the time that I'm doing the hooking of the resource and the stack, I just want to hook both of them just so that if the transform that you're adding for some reason is applying to the stack, it'll work just fine. So there you go. That's it for today, and hope you really enjoyed it. And thanks a lot, everybody. I will see you in the next one. Bye-bye.